Assalamu alaikum. Can you hear me?
Yes, sir, we can.
Okay, good. Thank you. I'm still saying that some of you haven't write your ID number, as I told every day that you have to write your ID number beside your name. I'll get that and then screenshot so that it will be coming without. Shayan Khan, please do it faster. And Tausif Ahmed, you didn't do yet. Tausif Sayan, write your ID number beside your name bit faster. When you come to the class, just write it down, your ID number beside your name. I think you are not in the classroom, right? Tausif, are you inside?
Yes, sir.
Okay, write your ID number. And Sayan Khan? Sayan Khan, are you here inside the classroom? This is what he thought that, okay, anyway, that rest of you, please, those who join, please check your ID number you have written. I'm going to take the snapshot before the classes start. Okay, number one. Number two is, today we're going to start the class with the servo system time response analysis. That's what we have started earlier. But tomorrow, all of you are having the class test, CT2. The syllabus is, I told you already, the reduction technique, both the canonical form as well as the Mesoscale form SFG will be included. Those two topics you have to study well, and the syllabus will be for that. So it's very short and 15 minutes time, 5 minutes normal. So what happened tomorrow, the class will be starting from 7 o'clock. Class means the class test. Class test will start from 7 o'clock. Within 15 minutes, test will be over, 5 minutes processing time. And after that, there will be no class, finish. So you have to be there only for 20 minutes tomorrow. I think you are having class test tomorrow, right?
Yes, sir.
Good.
At 7 p.m.
At 7 p.m. right? So 7 to 7:20 actually is the time, total time you have to stay. After that, you can go because there is no class unless you have any question or any discussion or anything. Okay, now that's all for the thing, and I hope that everybody get ready for the class test, and it should be together, section 1, 2, and whatever it is. My question is what? I have sent a email to you just today. I hope that some of you have seen already regarding a webinar, as there is going to be another webinar this coming Friday, but this is going to be organized simply, it's solely from IEEE student branch. Actually, IEEE student branch it's organizing this one. It's not the IEEE departmental one, but IEEE student branch is going to organize this. And I have already forwarded the what do you call that, the invitation to all of you, and I hope that you will be attending the seminar on Friday same time, 9 o'clock, because the speaker from US, from Texas, and then it will be, you know, the timing is their morning time and our evening time. So 9 o'clock is the best time we found actually. So I think all of you try your best to attend the webinar, and those who will be attending, I'll be recording there as well, so that you know that you will be benefited from both point of view. That means you will benefited from the technology. You come to know actually what's going on, and at the same time you will be advantageous position in the class. Actually, this I'm thinking some weightage for that because of you're gathering some knowledge. So it's a part of the education. Remember, seminar attending seminar is very important part, because you are going to be familiar with the cutting edge technology. It's not a seminar that all the Bollywood filmmaker or Hollywood filmmakers are coming there and you are getting the knowledge about the how to make a movie. Okay, it is the webinar on your EEE electrical electronics engineering field. That means this is very much related to your study. So all of you, I hope be benefited from that point of view. So I wish everybody should attend the webinar, and don't miss this opportunity, full stop, from all points of view, knowledge gathering as well as advantage from the class attendance. So I'll be noting down, as you saw last time, I have taken the attendance P for everybody in the last webinar. So this time, I think those who missed, you should be careful. Like Tausif Ahmed, Salman Kaulam, Shahyan Khan, Tahsin, then Aminul, Azraf, Tahmid, these guys, a couple of them, other people as well, a lot. I cannot name everybody. These guys were present in the last webinar. Of course, they should get some advantage from that, and I'll let you know at the end. So you can carry on. I hope that all of you will try you join the seminar. All right. Hopefully, everybody got my email regarding the webinar for this Friday. Just you can try your best. Okay, now let's come back to the point. We are going to start the class. If anybody got any question, anything regarding the node, what do you call that, reduction technique, canonical form or Mason's gain form or SFJ, at the end of the class we can discuss, or you also, I hope, that can talk to the student tutor, and you among yourself also can discuss. So I think that should be fine. Now let's go and start the class. All of you, please check the thing is working fine. The system is, you can hear the sound, and you can see the screen, all these things. Can you see the screen first thing first? Hey.
Yes, sir.
Okay, good. Now you check the sound system is okay or not. Is it okay?
Can you make it a bit louder, sir? Because
it is already louder. Actually, you can increase your volume knob. I have given the maximum. Hey, rest of you, can you hear the sound?
No, sir.
Okay, I'm
No, sir. No, sir.
Oh, okay. Then maybe something wrong. Oh yeah, yes. Okay. All right. Can you check now your real part? Can you now? Okay.
Yes, sir.
Yes,
Okay.
sir.
Okay, go carry on. Everybody be ready, because I'll ask a question. All of you, live class, I'm talking to the live class. All of you can remember last class we came up to this. C by R, second order, S squared 2 j omega and S omega square equals 0. The pole to two conjugate poles, we found how to find the two conjugate poles. We have found S1 equal to minus j omega and plus j omega and root over 1 zeta square, S2 equal to minus j omega and minus j omega and root over 1 minus zeta. These are the two closed loop pole, conjugate pole we found in the last class. If you open your class note, you can see that. Okay, I hope you all can remember. Now, from this point onward, we are going to see today actually how to analyze these two closed loop poles, and these two closed loop poles, how it is affecting the time response of the second order system. Second order system means servo system, we have to understand, because the zeta omega value we know already in terms of kjb of the servo system. So you can understand it. This is the servo system closed loop pole. Okay. And later on, we can see today that how this closed loop poles location affecting the system stability. That is very, very important on the S plane. That one will be coming at the end. So step by step, we are going through. Yeah, any question? No. Okay, let's go. This is real part. Real part is equal to minus zeta omega n, and imaginary part omega n, omega equal to imaginary part is equal to that one, omega n root over 1 minus zeta square. So this is what the j omega part is, this one. So you can see that real part and imaginary parts are coming like that from this. Now, we are going to locate these poles on the S plane. Before going to locate the pole on the S plane, we'll have to see first the one thing, that the time domain equation of this transfer function of the second order system, how this responds with time, that one we are going to see first. Look at this. That means if you go for, just look these things, that if you say this is the servo system, second order servo system, this is omega n, and this is s square. Time response, if I apply some step input 1, if we apply some step input 1, I think you're very much familiar with this, RT, then what will happen in the output? We are going to get the what? We are going to get the output like this on some sort of gate, some sort of output like that we are going to get, which is CT, and this is what we got is a RT is the input. RT is the input. That means this blue one, the blue one is RT, and the red one is CT. So blue one is the input, and this is the output. You should get something. Output you will get due to some input. Now this thing is in the frequency domain. This equation is in the frequency domain S, but this response I have drawn in the time domain. Now input is step input, output step input means, let's say 1 degree. If put 1 degree, output will be how much? It will be settled down to 1 degree. It's go up, 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 and in the long run it will go to 1 degree. If it is 1, 1. If it is 30 degree step you give, then it will slowly go back to 30 degree, mixing with 30 degree. So it's a step. 5 volt is a 5 volt is going to be. So like that is about time response you can get at the output. But how you get it? That's the question. Now look at it. I'm going to show you that part. Now you look carefully. C by R, we got something like this, omega n squared divided by s squared plus 2 zeta omega n s. You have to do what? You have to take Laplace inverse transformation. You get the equation from the Laplace table. You should get this thing as e to the power, e to the power minus zeta omega n t. This is zeta omega n. You can see Laplace inverse transformation gives you, if you take the Laplace inverse transformation, you get the equation from the Laplace table. You should get this thing as e to the power, e to the power equal to what? You want to find CT equal to what? Time domain, you have to do what? You have to take the Laplace inverse transformation, because you know, oh, you cannot see the thing, right? Not coming here. Okay, I have to, now you can see Laplace inverse transformation gives you, if you take the Laplace inverse transformation, you get the equation from the Laplace table. You should get this thing as e to the power, e to the power minus zeta omega n t. This is zeta omega n. Okay, zeta omega n t divided by root over 1 minus zeta square, and this is sine of, okay, I'm asking to the what do you call that, hello, can you hear me? Live class.
Yes, sir.
Okay, can all of you tell me this gives you the time domain equation, and that one we are, after getting the Laplace inverse transformation, we are getting that one. I have already gave you the, I have already sent you the Laplace table. All of you open the Laplace table and find out which equation actually gives us this information from the Laplace table. Raise your hand if anybody can. You'll get 0.1 marks. Look at the Laplace table I have sent you. If you cannot find it, you can find it in the BUX. The Laplace table I have sent you a long time ago, and search for it. Which equation should give us this information? The relationship between time domain, frequency domain. This is the frequency domain. Okay. One more thing. One I can just tell you. RS. Okay. Look at it. Okay, just a minute. If you consider RS equal to 1 by S, okay, you can just think about RS is 1 by S. If RS is 1 by S, then it will be multiplied with 1 by s. In that case, which equation? Can you tell me? If you raise your hand, you please let me know. Anybody raised your hand? Which equation? I mean, number. You can tell me the number. I think all of you can. I think you can see the screen, whiteboard. I'm talking about C by R equal to omega n square s square plus 2g to omega n s plus omega n square into rs. Rs means 1 by s. So this is what, don't be confused. This is rs. And rs means 1 by s because it's step input, right? RT equal to 1 unit step gives you RS equal to, everybody know that RS equal to 1 by S. So if you substitute 1 by S, then you are getting the thing equal to what? You're getting the thing equal to S into S square plus 2j to omega n S plus omega n square. Okay. And on the top is omega n square. So this is your C by R. C by R, sorry, this is C. This is C equal to, because R is multiplied there. So you understand this is C. So if you want to find this is C. Now you are going to find CT, taking the Laplace inverse transformation. Now, what is this? Which number? Anybody can tell me, or raise your hand. From Laplace table, LT. Hey, anybody raised hand? On, can you hear me? Hey, Dux, can you hear me?
Yes, sir.
What I'm talking, nobody responding. You try to get my point, or you could not find your Laplace table yet. Is it the Laplace table I send you? Yeah, who?
Sir,
Anybody?
couldn't
Nurjahan.
find
Nurjahan.
yes, I
Yeah.
couldn't find the Laplace table.
Okay,
in
okay, I
the-
understand
Yes.
it. Is it in the BUX? You cannot find it as well, is it?
Yes,
Yes,
sir.
sir.
Okay, I sent the email to you. That one also you couldn't find from there as well. Is it something like that?
Yes,
The
sir.
email, the course materials I have sent there, I didn't send you all the things. No. You could not find there as well. Is it?
So Laplace was not there.
Just a minute. I'm going to see the thing. I'm just wondering because of Laplace table. Laplace table is there. Anybody find?
Sir, can I attempt? Because I was seeing Laplace.
Yeah, just a minute. Let me solve this problem. Nobody got the Laplace table, right?
No, sir. No, sir.
What are you talking? Introductory slide, assignment, course. Okay. All right. All right. Okay. All of you get ready. I'm going to send the Laplace table by email and you will get it now. Okay, just 1 minute. I think I have put it there. Very much wondered about these things. Okay. All right. U5 Laplace table. Laplace, okay, and no one is having any Laplace table from the just a minute. Okay. The email I have given you, it should be there as well, I think, but you cannot find it. A bit wondered. Okay. 5. Laplace double is 1. Laplace 2. I'm giving you 2 pages. LTT pages, 2 pages. Can you? Okay, just a minute. Okay. Have you got my email now? Hi, you got my email? Not yet.
No, sir.
No, sir.
No. Okay. You'll get it soon. I think because just it's a matter of 1 second, maybe you will get it. Okay. I'm very much wondered about this thing. I didn't send it. Okay, no problem. Once you get the email, you open the Laplace table. I have sent you 2 pages. Each page give you the 1 to 26, and another page give you next 26 to 25, like that. 2 pages Laplace table I have sent to you by email. You open it and tell me which one should be applicable for this transformation, which number in the table. Now anybody got the email?
Yes, sir. Got it.
Okay, now you check
Got it,
which
sir.
which number. Now you raise your hand already. Okay, Jannatul Naim is very fast. Yeah, Jannat, tell me what is your answer.
I think it is 24.
What? 24.
Yes, sir.
Hey, what happened? Jannat?
Yes, sir.
Okay, Jannatul Naim or Jannatul Firdaus. What is that?
Jannatul Naim, sir.
Naim, okay. 0.1 if it is correct. Let's come. 24, right?
Yes, sir.
Let us go and see. Laplace inverse transformation, you get the equation from the Laplace table. tan inverse root over 1 minus zeta square divided by zeta square divided by zeta. So this is going to be your equation for the city. If you go with the this is t, remember, omega n t. If you go with the equation, this is the 3. You have done the Laplace transformation. You saw the table there. In Laplace transformation table, you can see the thing. Look at the table here. I think you all can see the table. Can you see the table number 24? Can you see 24? Hey, this one. Can you see?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now, if you look at this thing here, this gut, is it similar? Okay, you can say, sir, what is that thing coming from? Okay, look at it. I'm just going to see. Now, what is the R? Your RT, look at it very carefully. Step input in 243 signal system you have started. If unit step means RT equal to 1. Right? Unit step input means RT equal to 1. And what will be RS? RS will be what? Can you tell me? RS will be what? Laplace transformation. If RT is 1, step trans, what is that? 1 by S, right? Do you know that? Hey, do you know S? Then your equation is coming here as what? Okay, I think it's not what you get. RS value, you substitute the value of RS as 1 by S. If you write 1 by S, then whole thing you have to, you can just multiply a S underneath. Can you do that? Look at it. Instead of RS equal to 1 by S, if you substitute, then S you can put it back and then you can get the equation like that. Yes or no? Do you understand it? Anybody can tell me from your good microphone. Or do not get it?
Yes, sir.
Okay, if you understand
Yes.
now, yeah, look very carefully. This is the equation we can see in the Laplace table. Number 24 here, I'm talking about here. Can you see this equation in the circle, red circle? What do you see this big picture? Then it will be much more clear. This is the
Sir.
frequency domain equation. And this
Yes,
is
sir.
your, yeah, this is your
Yes, sir.
CT. Yeah, I think you can clearly see this thing. This is your CT equal to what I
Sir.
have written. And this phi Anybody from the real life class want to ask any question?
Sir, is it from 24 or 22, sir?
24, because you see omega n squared divided by s into s squared plus 2j to omega n plus a. Because after substitute the value of rs, which is 1 by s, then you get the equation of cs. And 22 is having what? Omega n? Is it, what is that 22? Okay, let's go to 22. What is written there in 22? Yeah, 22 is, can you say, who asked me the question?
Yes, sir. I am, sir.
Tausif. Okay, Tausif,
sir.
can you see 22 is omega n squared divided by this thing?
Yes.
Okay, so this is C by R, isn't it? This C divided by R.
Yes, sir.
But our target is to find what? C only, not R, right?
All right.
So
Thank
you have to multiply R. R is 1 by S, and that's why it is 24, not 22. Good. You cleared everybody. Thank you very much. Let's go. It is equal to what I have written. And this phi is replaced as this phi. Phi is nothing but tan inverse root over 1 minus zeta square by zeta. So this is the equation actually I have written over there, over here. Can you see the equation now? What happened?
Yes.
Yeah, the same equation, e to the power thing, I have taken it up. That's it, nothing else. Now, if you look at this equation very carefully, what I'm telling you now, listen carefully. If you look at this equation very carefully, you see the t is here and t is here. Can you see this 2t? Hey, can you see in the equation?
Yes, sir.
Yes, sir.
Okay, this t is the variable with respect to time. Actually, ct means t is the variable. Okay, now all are constant except t, you can imagine. If it is the thing, then how many functions are there in the equation? There are two functions. One is the what? One is exponential function, which is exponential decay, this one. Another one is the sinusoidal function, this one, right? Sin omega t plus theta, like sort of things. Got it? Hey, dumb. This is like sin omega t
Yes,
plus
Yes, sir.
theta. Yeah, this is the one. And is it multiply with this other one will be e to the power minus tau t, like sort of things. So this and other things are all constant, all are one or constant. Only these two are time variable and these two part are multiplied. So this sinusoidal part and the exponential part are multiplied together, and one is the DC value. One is the DC value means it is the constant DC. On top of that, the addition of these two things, one is exponential and sine wave. So exponential and sine wave multiplication is something like this. Look at the thing. Exponential curve, exponential decay. It's an exponential decay. Exponential decay means something like this. Like this way, it will die. I'm sorry. Okay, I'm going to draw it again. Something like this. Exponential decay means it is dying slowly. Exponentially, it is dying. And sine wave is, it is multiplied with the sine wave. Sine wave is something like this. Okay. Sine wave is something like this. You can just imagine. Like this. Oops. You're very much familiar with the sine wave like this. So if these two things are multiplied, okay, a sine wave and the exponential decay, if they are multiplied, the resultant will be what? The resultant will be, they are going to equal to what? They are going to equal to like this. That means the sine wave will be dying slowly. The sine wave will be dying exponentially. Exponentially, it is dying like that. That means in blood will be slowly dying. Slowly dying. So this is what happened. The exponentially, it will be exponentially, and that is the case coming here. And it is adding with 1 plus minus these things. Means this is addition of the DC value 1. So if it is addition with the DC value 1, then this will be running on top of 1. That is, this is 1 is a 1. So this is going to running on top of 1, and slowly it is dying out. Like that is the thing coming. And that's what we saw from here. You can just see this waveform. Is that waveform we can get for CT in this way. On top of 1, the CT is riding, and sinusoidal, it is dying out slowly like that. And it is dying out to 1. You all clear about it? The CT waveform? I cannot hear you. Okay, at least someone who is. Okay, I'm talking to the live class. This is very important point. All of you need to understand in order to understand the second order time response. So all of you clear about how the output curve CT, the red curve, comes from. All of you clear? Live class. Hello.
So can you explain bit?
Not very well, sir. Can you repeat it again?
Okay, listen carefully then. In the question, time variable will 1 is going to affect. Okay, I'm going to tell you here to a live class. Listen carefully. If you have any question, you can tell me. This equation CT equal to this, that part you all understand, I hope, from the Laplace table straight away you got, because this is the frequency and time domain relationship. So like the R equal to 1, R is equal to 1 by S. So 1 is converted into 1, or 1 by S can be converted into 1 through the Laplace inverse transformation. Like that, this can be through the Laplace inverse transformation. We can get the time domain equation like this. Now we are going to draw this equation. And this is your output equation CT, that what we are going to draw here. And that's we have drawn like this arbitrarily, because the question is how this, what is the equation of this line? That is my question. That is our question. That equation is this equation actually. How it is that actually, that one it is explained here. Because in this equation, you can see one is a constant value, then minus, and this is a whole thing got two function actually. Function means like CT is a function of time. So this is one function, which is the function of time. Another function is this one, which is on one function of time. There is other things, zeta omega and all guts are fixed and constant. So E exponential time is exponential decay, to the power minus tau t, like that, you know that. So it's an exponential decay function, and this function is sinusoidal function. Sin omega t plus theta, you know that sinusoid. So this got full thing is omega and t, and this whole thing is theta. So you can say that sin omega t theta. You know that sine curve is like that. Is the delay function. Theta is delay angle, and this omega t sine theta. That one you all understand, the sine wave, and this is exponential decay. So these two are multiplied here. That one is over here explained. That sine wave, if you draw, if you go for the sine wave is like a sine wave. Everybody know that. And the exponential decay is like this. It says dying exponentially. If it is e to the power plus tau t, then what happened? Then it will exponentially go up. Right? You all know that it is going upward direction, exponentially up. But it is minus tau t means exponentially dying, like that goes to 0. Now these two functions are multiplied, means these two curves are multiplying. If you multiply these two curves, then the sinusoidal curve will multiply with exponential decay, and then the sinusoidal curve will be dying exponentially. This is what it is told actually. You can see this this sinusoidal curve and the exponential curve multiply and give you the sinusoidal decay. And 1 is the constant value minus the whole thing. Just imagine that 1 is the DC value, that is a constant value, and the whole thing is riding on top of 1. That's why the sine wave is jumping up on the DC value 1 and then dying out exponentially. And that's what we got over here. And that's why the whole thing is giving us this sort of response, which is exponential I mean, the sine is dying exponentially at the final value 1, because 1 is the DC value. On top of 1, that is the sine wave is going to die slowly exponentially. That is the way actually the whole CT equation is giving us this sort of response curve. Now you understand, some of you at least. Hey, what happened? Is it okay now?
Yes, sir.
At least better, right?
Sir.
Okay, now let's go and see after that the system over here.
Is RT value is always fixed? I mean, 1.
RT we are going to consider fixed in this case as input to the system. You can input ramp input, you can go for parabolic input. I think you have studied all this sort of input in EEE 243, right? Or forgot it? Impulse input, step input, ramp
Yes,
input,
sir.
parabolic. Okay, this is
Yes,
what
sir.
the step input we are considering in case of this second order system, servo system, because now we are saying a step. Remember the two potentiometer, input potentiometer, you apply 30°. So it is a step you've taken from 0 to 30, and then the output is going to be like this. You know, that's like this way. It is going up and then going down, 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 down to 30, like that as oscillation, and then it's jump back slowly, it goes to 30. Now as a control engineer, your job is to make it more smooth so that oscillation will be less, peak overshoot will be less, a lot of analysis you have to do, but the response will be like, so for a step input we have to do this analysis because that is step input you are giving. But if you say, sir, I want to give a smoothly changing input, the ramp input you want to apply, you can apply ramp input, you can apply parabolic input, you can apply different input, and you can see the performance for different input. But we are not going to analyze, we are not going to consider all inputs for one thing. We are just going to suitable input, which is a step input, very much reasonable, and for system performance analysis, this is more than enough. Yes, this is a constant, and I know that, I hope that you know about the step input in 243. How is that? It's a constant, but in our case it is a unit step we are considering, and that's why the magnitude is considered as a 1. Now if the step is a 30°, you can say this is not 1, it is 30. If the step is 5, there is a 5 volt, so you can guess a 5 volts, 1 volt, 1 volt, like that sort of things. So it is fixed, it is constant 1, and that is what gives you 1 by S, and based on that you are going on. I think you are clear about it. Should be fine, right? It is fixed, constant. So there are 4 categories, we can say the 4 categories based on the zeta values. One is called, if the zeta value is 0, first thing, 4 categories based on zeta value, based on zeta. That you are telling that what is the impact of zeta, what is the effect of zeta, the performance, that's what I'm talking. Therefore we can categorize into 4. The first category for zeta equal to 0, zeta equal to 0, it is the category we called undamped case. Undamped case. Undamped case. And if zeta value, this is number 1. Number 2 is for, so zeta value, based on zeta value from 0 to infinity, right? This value cannot be more than the maximum 0 to infinity. Minimum is 0, maximum is infinity. That's the variation of zeta. So if I start from 0, zeta equal to 0, there's an undamped case. It cannot be negative. So it should be from 0. So, and for zeta is, let's say, more than 0, but less than 1. If this is the scenario, then it is called, this is under damped case. Under damped case, and under damped case is coming there. Okay, then I think I'm writing very closely. I can write, okay, if I go for 1 by 1, then it will be better. In that case I can understand the space required. Okay, undamped case, if you go, then the response, if zeta equal to 0, then what happened? The response is coming like this. T, and this is what happened? 1, 1, 1, that, and then the response will be like this. It's a oscillation is going on. Okay, oscillation, simply oscillation is going on like that. That means for this case, zeta is 0. Zeta is 0, then you are getting only the oscillation, only the sine wave you are getting, actually no other things, because you can understand from the equation. Hey, look, if zeta is 0 here in this equation, can you see what I'm talking? Zeta, hey, this exponential part, if zeta is 0,
Yes,
e to the
sir.
power 0, 1. So only, and this is only the sine wave is, sine part is there, but the what do you call, the exponential part is 0. 0 is 1, e to the power 0, e to the power 0 is 1. So only in the CT equation, it is the sine wave, right? 1 plus some 1 minus some sine wave. So it is a equation of sine wave only. That's what you can see. It is a sine wave you are getting as a simply undamped case you are getting for that. Now, if you go for number 2, that is your for zeta, as I showed that zeta is less than 1 but more than 0. If this is the range, a real life class, do you understand why this is a sine wave? Because zeta is 0. If zeta is 0, then exponential part is going to be 1, so only the sine part is there. That's why it is only a sine wave on top of 1. Do you get it?
Yes, sir.
Okay, good. Thank you very much. We go. It is called under damped case. Ting, 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 ting. And your response is coming like this. Okay. And 0 to 1. And this is the very important part. And this is the operating part, actually. This is the operating part for the servo system. So under damped case, this is the case. And a zeta value, based on the zeta value 0 to 1. What does it mean? 0 to 1 means what? It can be what? Any value. Can you tell me in between 0 and 1? 5 can be in between 0 and 1, right?
No, sir.
Okay, I'm just asking this question to one guy and be ready to start answering question. Nehal, are you there? Ashik Haidar Nehal? Nehal, are you there? Okay. You don't want to answer? Okay.
Yes, sir.
Yeah, what do
Hello.
you think about any value in between 0 and 1? 5 can be answer. Is it 5 can be a value of zeta in between 0 and 1?
No, sir.
What
0
is that?
point 0 point something 0 0.1 or sir
0
0 point
0.1, 0 0.2 like that. So
Yes,
up
sir.
to 0
0 0.99999
and
yes.
1.9 can be as well.
No, sir.
Good. So this is what in between the value of zeta can make it under damped case. And this is our main thing in servo system works under damped case, under damped case. Now let's go how it is happened like that. 4, 3, 6, all these is going to die or increase. So let's say I'm telling you here, there's a, this is zeta equal to 0 0.5. Zeta equal to 0 0.5 is giving you this value. Now, if I say that another response is coming like that, like this, and another response is coming like this, the green one is smaller. Okay, now my question to you all, what can be the value of the blue form and what could the zeta value and what will be the zeta value for the green one? Okay, live class, you raise your hand, those who can answer this question. If both questions are correct, you get 0.25 marks. Raise your hand. Hi Farhan, why you raise your hand before the question?
Sir, I was actually following the class, so then.
So
it said to
you cannot answer, right?
Yes, sir, I can answer.
But anyway, I'll ask you later because Jawadul Alam, hey, all of you, what happened? Nobody can understand what is the question. The question is what should be from this is zeta equal to 0. Now, assume middle one is zeta equal to 0.5. Question is what should be the value of blue one and what should be the value of green one? Zeta value what for the blue one, zeta value what for the green one? Just approximately you have to get the idea. That's the question asked. Now all of you, Jawdul Alam, you go ahead. Blue one
Sir,
is what?
sir, blue one is less than 0.5.
Yes, for example,
Sir, that's the 0.2.
0.2. And what about the green one?
Is greater 0.8 or 0.7.
Good. Now let's go. What is your idea? The zeta for the green one will be what? Any value you can tell me. And zeta value for the blue one is what? Can anybody tell me any value? If the middle red one is 0.5.
Sir, blue one maybe 0.7 and green one maybe 0.3.
Okay. Do you agree with him? He said the blue one is 0.7 and green one will be 0.3. Do you agree?
Yes, sir.
Now look.
Sir, I think the blue one.
Sir,
will be
I said
0.2.
other way around.
Oh, you
sir.
said
The
other way
green
around, maybe.
one 0.7.
Okay, good. If it is other way around, it makes sense because why? The less the zeta value is going, it is going towards the oscillation, which is zeta equal to 0. So from that point of view, it is other way around is correct. Now we can say that other way around means what? Other way around means and this is we can say 0.3 rather. When it is 0.3, if it is 0.2, it will be much more bigger. When it's 0.3, 0.1, it's much more bigger like this. When it's 0.5, it is much more bigger like this. When it's almost 0, it is just an oscillation going on like that. So this is the way, the less the zeta, the more it is going towards oscillation. From that point of view, the top one will be less, that is 0.3, and green one will be 0.7. So that makes sense. Now I think everybody understood it, how the zeta value changes. What does it mean? It means the peak. You can see the peak overshoot. Peak overshoot means this is the peak. The peak will be increased with the zeta decreasing. That is what we can see here, right? The less the zeta, the peak will be increasing, and you can see the maximum peak you will be getting at zeta equal to 3, which zeta equal to 0, which is a undamped case we call. That's the maximum. Another maximum thing is what? For definitely you understand what will be this value. This will be what? Zeta equal to 1. This is the limit. This is with this value. This will be what? Zeta equal to 1. This is the limit. This is called critical damping case. Critical damping case. Damping case. Critical damping case is like something, you know what, again the internet is unstable. Okay, no problem. Critically, I'm just finishing faster. Critical damping is coming like this. 1 RT, and we have another 10 minutes to go also. Okay, if you go like this, okay, like not like that. Okay, you go a little bit up and then you go like that. Okay, some more steeper. You can just like this and like that and go straight. This is your critical damping case, that zeta equal to 1 is giving you a critical damping. That means this first one and last one, zeta equal to 0 and zeta equal to 1. These two guys are working like a saturation and cutoff. And the middle one under damp case is an operating region of a transistor, you know, like that. That means these two are extended limit, and in between 0 and 1 is the operating region. That's what servo system actually operating in between 0 and 1, which is under damped case. So this is the servo system's operation. This is the operating at this point. This is the operating servo system operating in between 0 and 1, that is the under damped case. And if it goes to 0 is undamped and is a critical damp. These are two extreme limit. And also there is another case you can see in reality, that is, what is that one? Exactly, you understand that that is if zeta is 1. If zeta is more than 1, it can go up to infinity. So that is the range actually. If it goes above 1, then it is called over damped case. That's a special case, over damped case. Over damped case will be what? It is very unlikely. So we can say that if it is like that, as you understand, slowly the response is going down. So under damped case is much more down like that. So this is when zeta is more than 1, it is going more and more away from this. So this is what the over damped case you can see. So these are the 4 types of damping based on the zeta value, and according to that the response curves are like that. But mainly our target in operation is this one. This is the operating case, and this is what is the required operating of the servo system or any second order system. Other cases are the extreme and constraint. Now we are going to see that if these are the 4 different type of cases, then there will be 4 different type of equations of the second order system coming from it. Like that one I'm going to show here. Example equations for the system. What is the response of this thing supposed to be? Okay, this is an open question to you all. Hey, live class I'm talking about. I'm going to ask the question. All of you can go ahead. Okay, first of all, open question to everybody who can answer. What is the omega n value? What is the zeta value for this particular second order system? Raise your hand. Okay, Khadija started first. Khadija, you tell me what is the omega n and what is the zeta?
So omega n is 5.
Khadija,
And
what is that 0.1 marks you get? Omega equal to omega n is 5, right? And what is zeta?
zeta is 0, sir.
Zeta is 0. So what is the case? What type of case actually?
Undamped.
Undamped case. Excellent. So you get 0.1. Thank you very much. Khadija. Now all of you can try to get it. It means what is the damping and what is the response of these things? You tell me. What is the damping? What type of damping first? 4 cases I told you. Among which cases? And then you draw the response curve. Can you tell me what is the case? Is it what type of case? Is it under damp, over damp, undamped, critical damp? Anybody can tell me. Zeta value, you can easily tell me what is the damping case. Okay. Now, how to find that thing? You can see standard equation is omega n square s square plus 2 zeta omega n s plus omega n square. This is the standard second order. And if you compare it with the standard second order, then omega n square will be equivalent to 25. Always from the lower part you have to go. So omega n square is 25. Omega n is what? Hey, come on. Omega n is 5 radian per second. Is it okay? Hey, tell me yes or no. Understand it?
Yes, sir.
What is this? All
Yes,
silent. Okay.
Yes, sir.
And what is the 2 zeta omega n coefficient? 2 zeta omega n equal to what? From here.
0, sir.
Absolutely good. Omega zeta.
0, sir.
Any children didn't born yet can tell me the answer. Zeta equal to what?
0.
From this into it. Come on.
0, sir.
Are you okay? Yes, I told
0.
you any children didn't born. It's a worst case scenario if you cannot answer. Okay, then it is becoming a big 0 because omega n you substitute 5, no problem. Because zeta 2 into the 10 zeta equal to 0 means zeta equal to 0. And anybody should understand it, that this thing, right? Hey, what happened?
Yes,
It's
sir.
5 radian per second. This is 0. If it is 0, then what sort of damping? Can you tell me? What
Under
type of damping?
Under damp, sir.
Or you kill yourself better.
damped.
That's why it is happened. Undamped case. So you have to answer the question like this, that it is an undamped case and, oh, sorry. Yeah, undamped case, and undamped case means this is the way you have to find undamped case, and your answer will be undamped case, and your result will be like this. What your result is, can answer this way. Now I'm telling you here, can you tell me what is this thing here? Tell me. 9 divided by s square 6s is here. Tell me, all of you. I'm going to ask the question, open live class. You have to tell me the answer for omega n and zeta value, and then you get 0.1 marks. Okay, Mashfiqul Islam Khan, can you a bit faster? Mashfiq, what is the omega n and what is the zeta value for this problem? Mashfiq, are you there?
Yes, sir, I'm here.
Yes, sir.
So
Can you-
omega n is 3.
Good. And zeta is?
Zeta is 1.
2 into 3 is 6 and 1. Good. So if it is zeta is 1, omega n 3 and zeta is 1, then what sort of damping?
So critical damping case.
Good, absolutely. How you know this? I underestimated you and you did the answer. Very good. I am very much happy with you because you are in the red zone. Okay, thank you very much. You got 0.1. Your answer is absolutely perfect. I think, what's your name? I don't got it. Mushfiq, is it Mushfiq?
Sir, Mashfiqul Islam Khan.
Mashfiqul Islam Khan. No, thank you very much. Yeah, you're right. You do it on the paper and then tell me that anybody can get the answer. It says plus 16. Now again, you do it for this. And I'm going to tell now the question number 3. Be ready. I'm going to call your name. He has to answer. Okay. Now next question, Sakline. Sakline Jaman, are you here? Sakline Jaman. Okay. Sakline is not interested to answer. Okay. Now Rafsan Khan, are you there, Rafsan?
Yes, sir.
Can you answer to this question and get the marks?
Yes, sir.
What is
the value of S? The
I'm
value
asking you omega n equal to what in this problem?
omega n is 4.
4. Good. And what is zeta?
Sir, zeta is, sorry, 1.
1. Okay. So all of you, is he correct or not? Just tell me yes or no.
Sir,
No,
I
sir.
I don't give it.
No,
If
sir, no.
anybody give me the answer, he will get negative mark. I'm asking you only one question. Yes or no? No, sir. Good.
No.
No. That's the answer you should give me. Now I'm asking the question to the next guy. Jannatul Naim, are you there?
Yes, sir.
Hey, Jannatul Naim given me one answer before. So you should be there. Okay, now you tell me what is the answer? Zeta equal to what? Bit faster.
So zeta equal to sir, 0.5, sir.
0.5. Okay, is he correct? All of you?
Sorry,
No,
sir,
sir.
sorry, sir, 2, sir, 2, sir.
Ah, you have negative marks. Who said 2?
Sir, me, sir, Janatul Nahi.
Oh, Jannatul Naim said 2. Okay, is it correct? 2?
No, sir.
No, sir.
So Jannatul Naim, you cannot get the answer. Okay, you cannot get the marks. Now I'm asking you, Taki, are you here? Salman Taki? Okay, Salman Taki is not there. Tasnub Tahanab, are you there, Tasnub?
Yes, sir.
Yes. Where do you? Can you tell me what is the zeta? What omega n equal to 1? Omega n is equal to 4. Now the question is omega zeta equal to what? You have to answer. Now what is the answer? Zeta equal to what? Can you tell me?
One more chance. I think.
No, cannot. You cannot answer. Okay, no problem.
So can you give me another chance?
Who is that?
Sir, Rafsan.
Rafsan, you already got the answer from your friend, right?
No, sir. Sir, I actually tried to derive it from.
Okay, you tell me, Rafsan. No problem. What is the answer?
Sir, 1/4.
That is 1/4 means what? You don't have a calculator.
Sir, the zeta's value is 1/4.
1/4 equal to what? 0 point?
So 0.25.
That's why you have to answer, but your answer is wrong. You have a calculator or don't you have a paper? And Rafsan,
Yes,
just
sir.
tell
Yes,
me.
sir.
No, just tell me the truth. Are you having a class note in front of you?
Yes, sir.
What,
Yes,
paper?
sir.
Okay, in the
Yes.
paper, what you have written? 2 zeta omega n equal to what?
Sir, 2 zeta omega n I wrote as equals to sir as equals to 4, sir.
4.
Yes, sir.
Why? 2 zeta omega n equal to 4. Why you written 4? Because the coefficient of S, 2 zeta omega n, the coefficient of S will be equal to 2 zeta omega n equal to the coefficient of S. What is the coefficient of S?
Sir, 1.
So 2 zeta omega n equal to what?
Sir, equals to 1. So it's
So
going to be
if you again, if you equal to 1, then what is zeta equal to? If you omega n substitute the value,
sir, it becomes half.
half. Omega n equal to what?
Sir, omega n equals to 4.
So if substitute the value omega n equal to 4,
1 by
then
8.
what?
1 by 8.
Are you a student or a school kindi? This simple question answer you cannot give directly after telling you A to Z everything, then you give me the answer correctly. Okay,
Sir,
I'm giving you 0.1 marks, but next time onward, you
Sir, I'm so
cannot
sorry,
answer. Yeah, be careful. Everybody should take your paper, pen, calculator, because this is class. Okay, I hope that next time onward, everybody should be careful about. Now I'm going to give you the next question and everybody should answer. Rapsan, I'm giving you 1 for this time being. Next time you cannot get marks in this way. Okay, go ahead. Let's go. This one, what is the omega n? You find it first. What is omega n? And what is zeta? And then from there, you can find the response.
125.
0.125. All of you got something like this?
0.125.
Yes, everybody.
Yes, sir.
Rapsan, you did it. 1.125. 1 by 8 means 0.125, right?
125. Yes, sir.
Good, good. So Rapsan, next to give you 0.1 marks, you have to give me the answer. The system is what? Which damping? The undamped, overdamped, critical damped, underdamped? Which one?
Sir, sir, it's going to be overdamped. So no, underdamped, sir, underdamped, sir. So it's
Right. So
less
be
than-
careful what you're talking. I am telling you again. Okay, good.
125.
0.125. You are all sleeping. Okay. What is the
Yes, sir.
damping? Yes, sir. You
Yes,
tell
sir.
me what is the damping then? What case? Is it undamped or overdamped or underdamped? Good. It is underdamped. Good. So underdamped case, underdamped case, and the, you know, is something here. Now you can see. Hey, can you see now? Okay. Now all of you, you have to do it on your paper and give the answer. Ask question, he will answer. Bit faster. Okay. Now this guy is now this time I'm asking. K to. Who is this guy? Mehdi Hassan, are you here, Mehdi? Bit faster.
Yes, sir.
Yeah, what is the answer? Omega n is what?
Omega n equal to 10.
10. How? Because you have to take always from the lower part, not upper part, right? Omega s square plus 2 zeta omega n plus omega n square. This equation is in the lower part or upper part?
Lower part.
So you have to take the lower part to find the omega n value, not the upper part. So what is that omega n then? You cannot understand if you write equal to.
Sir, 1.
Yes, why are you taking 1,000 years? Okay, if it is 1, what is zeta?
Sir, zeta equal to 5. Zeta equal to. Sir,
You have a calculator, you have paper, pen, everything.
yes, sir, yes, sir, yes,
Just
yes,
tell
yes,
me, what is that? You get 0.1 if you can answer. Can you?
2.5.
Absolutely good. Excellent. Beautiful. Okay, now you tell me to get full marks, 0.1. What is the damping? Is it critical damping?
No, sir, it is overdamped.
Absolutely good. I think you are very much attentive in the class today. I appreciate you. Thank you very much. And everybody should be like that. Good. Mehdi Hassan, thank you. You are absolutely correct in your answer. Let's see your answer. What happened?
N is equal to 100.
1 it can be drawn like 925. 2 guys, the numerator. So you look at the denominator. Denominator is the lower part. So lower part omega n should come from 1. So 100 is because of 100 gain can be there. Means I'm talking about this 100 can be here, and your and your system can be like this, like plus. But actually, you just go for 100 here, then things here, then 1 by things can come back here, C by R, like this. So these guys coming here together, giving you that value, C by R. So you can see that way. So 100 is a gain. It can be multiplied in front or in the later part, doesn't matter. So you don't need to worry about it. All what you have to check is the lower part of the thing. So closed loop poles part we have seen, right? I am pretty sure you are you are writing on the notes. So the closed loop poles are these, the poles. I'm talking about these poles. We are going to locate the poles on the S-plane. This is the S-plane location. S-plane got what? From here, we can say the S-plane is having the sigma and omega. The sigma is the real part, omega is the imaginary part. So S-plane should look like this. I think you are very much familiar with the Cartesian coordinate, where this is the real part and this is the imaginary. Imaginary axis is y-axis, real axis is the x-axis. So you can say this is your real axis, this is your imaginary axis, j omega axis. So this is called S-plane. This is your S-plane. S-plane is this one. Okay. As a S-plane. Okay, this S-plane, now we are going to draw the location of the closed loop poles on the S-plane. So hey, all of you can follow me. Yes or no? Tell me.
Yes, sir.
Okay, now this real axis value, this yeah, if you go and substitute, I have drawn the location of possible, all the locations of the closed loop pole on the S-plane. Can you see, hey, what happened? Okay, I'm talking to the live class. All of you can have a look of this thing. This is minus j to omega n plus minus j omega n root over zeta square. Now, if you substitute the value of zeta omega n for a servo system, zeta value, omega n value, you know that in terms of KB we have gone. So some numerical value after calculation you can find. After substituting zeta equal to 0.1 or 0.2, whatever, omega n 5, then you substitute, you get 2. And after substituting, you get 3. Like for example, so minus 2 plus j3 plus minus j3. Where is the location of this conjugate pole? Minus 2 means, can you tell me which one? The cyan, black, green, yellow, or purple, or red? Among these, which
Purple,
one?
sir.
Purple, good. Hey, everybody understand what is going on? Minus 2 plus minus j3 is the purple location, because minus 2 is here. Minus 2 plus minus 2, I'm sorry, minus 2 is here. This one, and plus minus 3. This is plus 3, this is minus 3. Plus 3j minus 3j. So purple location is this. This location is on the purple. These two purple point are actually indicating this minus 2 plus minus j3. And if it is plus 2 plus minus 2j3, then it will be what? It will be the cyan, this 2. And if it is, hey, if there is no 2, this is 0. Only plus minus j3. If it is only plus minus j3, then which color will be locating?
Yellow.
Yellow, good. It will be yellow, plus j3 minus j3. Excellent. And if it is 0 and this is 0, the real part 0, imaginary part 0, then which one here?
Green.
Green. Hey, rest of you are sleeping. Is it all of you understanding?
Yes, sir.
Good. Ask me if anybody confused. Now you tell me, if only minus 2 is there, but there is no imaginary, only minus 2, then which one will be that?
Sir, red.
Red one. This red one, minus 2. Good. And if this is not, imaginary is not there, it is only plus 2. If it is only plus 2, then which one?
Black, sir.
So you all understand the Cartesian form. The location of the closed loop pole, servo system closed loop pole's location on the S plane. We can it can be located on the yellow, means imaginary axis. On the imaginary axis, it can be located on the red, on the sorry, the black, that means on the real axis, on the right half real axis, or if it is on the -2, means on the red one, it will be located on the left half real axis. If it is -2 plus j3 like this one, then it will be located. The purple means is in the left half of the S plane. Left half of this imaginary is dividing into two parts. This is on the left side and on the right side. If it is +2 plus minus j3, it will be cyan. That means it will be located on the right side of the S plane. It means the first quadrant, fourth quadrant means the right side of the S plane, and second quadrant and third quadrant means it is located on the left half of the S plane. So this is all about the location of the closed loop pole on the S plane. I hope that everybody understood. Let us go and do the analysis. Response.
Yes, sir.
Yeah.
Explain. Rest of the here. Now going to draw this thing in a separate page so that location inside, then the location side here, and the look can see now by this time plus minus j omega n root over 1 minus zeta square. Okay, the locations of the poles at every point will be what? We got the equation for the CT as what? Remember, equal to 1 minus, I'm just writing it, e to the power minus zeta omega n t tan inverse root over 1 minus zeta square by zeta. This is what we got. Now, if the location is at the center over here, if the poles located on the center, then what will be the value of zeta and omega n? All then what can we say? That look at it. Then this zeta omega n is this will be 0 plus j0. This is the thing, right? Hey, can you see? Can you see the screen? Hello?
Yes, sir.
Okay, that means what? Zeta omega n, yeah. So that means that this part is 0, zeta omega n is 0, zeta omega n is 0, and imaginary part omega n root over 1 minus zeta square is also 0. So what does it mean? It means if exponential part and significant part all are 0, then it will be what? It will be 1 by root over 1 minus zeta square, and some sort of constant is coming there, because this part also 0 and this part also 0, right? So this two part 0 means it is a constant. The whole thing is a constant. There's no t terms coming, right? Real life class, do you understand because of the location of the closed loop pole on the center, how the CT is becoming constant? Do you understand? Real life class?
Yes, sir.
Good, excellent. Hey, I think we don't need to explain that much. If this is constant, then what happens? CT is constant, then what happened? CT. I think you should understand. You get my point? Hey, constant, because
Yes, sir.
yeah, t term is 0. So the response here in that case will be simply a constant. It will be a constant. The output will be like a constant output. So it will not affecting the system response. Okay, so I'm just going to redraw it on the other side, otherwise you'll be confused. Okay, here I'm just drawing it. Is it constant? It is constant coming there. A constant output is coming. Okay, now that means pole location here at the center means the real part and imaginary part both are 0 0. If both are 0 0, that gives us the output equation, the CT, as a constant, right? From there we can get a constant. So the response is like a actually we have to think the conjugate pole One is plus j omega, another minus j omega. That means both of them are on the imaginary axis. If it is on the imaginary axis, hey, every children know any point on the y-axis, imaginary axis means the y-axis here, right? This is your real axis. Oh, it is your real axis. I think you're okay. I'm going to ask the question to the real life class. You should give me the answer. Kaji Andalib Mamun, are you here, Kaji? Okay.
Yes, sir.
Okay, can you give me the answer to this question? You're on the green one, imaginary axis point. In the S conjugate pole, which part will be 0? This zeta omega n on the or the omega n root over 1 minus zeta square. Which one will be 0?
Omega n root over 1 minus zeta square.
You mean that this will be 0, right?
Yes, sir.
Because on the imaginary axis.
Yes, sir.
Okay. Who do not agree with him? Raise your hand. All right. Rafsan Khan do not agree with him. Okay, Rafsan Khan, then what is your answer?
No, sir, that was from previous. Actually,
Okay, okay, then I think it's all right. Now, next, drop down your hand if you don't. Asif Imran Khan. Asif Imran Khan, what is your answer?
So I think it will be the real part. That means minus zeta omega n.
This will be 0, and
Yes,
the imaginary part remaining the same, right?
Yes, sir. Because
Yeah,
the part is
you are
on
right,
the
Rafsan.
imaginary
It's all right.
axis.
Good. Thank you very much. Now go ahead. Understand it is a real axis, and it is your imaginary axis. Imaginary, which is a j omega, and this is your sigma. I told you earlier. So like that. So imaginary axis, real value is what? What is the in the y-axis? X value is what? Hey, what happened?
0, sir.
0. In this case, in the imaginary axis, the green point, yeah, green points are on the imaginary axis, on the y-axis. So real value is 0. And real value 0 means this is 0, fine, but this one is not 0. This one is minus j omega n root over 1 minus j square. That is as it is. Only the first part is 0, right? Zeta square. So not 0. So from here, these 2 points, the green points are coming this. This is the point we are getting. From here, now if you go and put the value into the equation, in the equation, you are putting the value into the exponential part. So exponential part, zeta will be 0. So you are getting this part equal to 1. So you are getting the equation as 1 minus 1 by root over 1 minus zeta square, a sine of some garbage. That means it is a sine wave equation, right? 1 minus on sine wave. So your sine wave equation means the response will be here, in that case, will be like what? The response will be simply a what? A response will be like, so one response will be like a sine wave. Sine wave means a oscillation. It's a undamped case oscillation, you know that. So it is the case here. Both cases are same. So you should get a sine wave here as well. So for both conjugate, plus minus j omega n, which is, if you go with this on, I'm talking about, okay, this part, I'm real axis location. A green point, this green point is, just now we saw it, the green point means the whole, it is representing the whole imaginary axis, remember. Any pole located on the imaginary axis anywhere, it gives you a oscillation output. That means it's a giving undamped case response. But here, if you go, if I take, this is the sample on the negative real axis. This is the negative real axis, right? Negative real axis side. From the origin up to the negative real axis, anywhere. This point can represent here, 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 anywhere on the negative real axis. I'm taking this one as a sample. Okay, if you take this one as a sample, then sigma will now real life people, you should answer to the question now. Be ready for this. I think next guy is your Taifur Rahman is not present. I think Ashrar Ibn Hussein, are you present, Ashrar? Okay, Ashar is not interested to answer. Khan Fahad Rahman, are you in? Khan Fahad Rahman, are you in, Khan Fahad Rahman?
Yes, sir.
Okay, can you answer to this question? If the location is here, then what will be the zeta value? What will be the omega n value? Omega value, real part and imaginary part. Which one will be what on the negative real axis? We have two value. You look at it. We have two value.
I missed the class because
Oh,
of
okay, no problem. Yes, all right, no
I
problem.
was not here. So.
All right, no problem. Just next time you have to be careful. Mahmoud Hassan, are you there? Okay, Mahmoud Hassan is not interested.
Yes, sir. Yes, sir.
Can you interest and get the 0.1 marks? Okay, for
Sorry,
this
sir.
you cannot, right?
Yes, sir.
Okay, no problem, no problem. Just concentrate. Okay, next guy is Fabliha Rahman. Fabliha, are you interested to answer?
Yes, sir.
What is the thing you think? What will be what? Real part and imaginary part. This is on the real axis.
So real part would be 0.
On the real axis, real part is 0, right?
Yes, sir.
Okay. Now let's come look at it. Concentrate with a real part is 0 means what? Which one is real part? Zeta omega n or
Sir,
omega n?
So zeta omega.
Oh, so you said zeta omega n is 0. That means zeta is 0. This is 0. Delta is 0. You said. Okay. Real part
Yes,
is
sir.
0 over here. You are saying no problem. Just watch closely. Next guy. I'm asking.
No, sir. 0. No, sir. Not 0. So minus.
Then which one will be 0? Okay. You need to be clear what you're saying, and then only you get marks. Okay. I'm asking Rifatul Islam Rifat. Are you here? Rafiul Islam Rifat? Okay, Rifat is not interested to answer. Said Ibn Shahid, are you interested? Shahid? Yeah.
Yes, sir.
Said Ibn Shahid. Yeah. What is the answer?
Sir, I can't.
Okay, on the real axis, which one is 0? Real part or imaginary part? That's the question. Okay. Okay, now let's come back to the point. Next, it's okay, no problem. You cannot answer. I'm not going to forcing. Okay, now next guy, Abdullah Al Jaid. Can you?
Yes, sir.
What is the answer? Tell me.
Sir, imaginary part is 0.
What is that? Can you read? Imaginary part is 0. I understand. What is imaginary part here? Zeta omega n. Is it?
No, sir. So J omega n.
You cannot see. Is it? Root over what? You need to know
1
what
minus
is
theta square.
right. So J should not be included. It is the imaginary notation. So only this part you can say omega n root over 1 minus zeta square equal to 0. This imaginary part is 0, right? Yes, yes, sir. Good. Now let us go and see. You wait. I'll ask you question. Will be what? Minus zeta omega n, and this guy will be what is that? The x-axis, y value is what?
The plus minus zeta.
Oh no,
omega
no. I'm
over
just
1 minus.
listen. This is x-axis. This is y-axis. You told me just now on the y-axis the x value is 0, right? I'm asking you on the x-axis.
Yes, sir.
What about y value?
In x-axis, y value is 0, sir.
What are you telling me? This is j omega is a y value, right?
0.
Imaginary.
0.
So this will be 0. Are you okay? This is 0. So this is what, okay. This is what you are getting from, sorry, what's wrong? Okay, you get something like this. Like equal, you can write here minus zeta omega n and plus 0, plus minus 0 you are getting here. Right, the imaginary value is 0. So this is the point you are getting on the, this is representing the negative real axis. If this is the scenario, then what is the value of CT coming here? 1 minus, this imaginary part is 0. Imaginary part means this part is 0. Omega n, this is the imaginary part, right? Imaginary part, you can see this imaginary part is 0. This is the imaginary part. Imaginary part is here. Absolutely good gut. So only exponential part without wasting time, sir. Tell us next. But there are some dumps. I'm worrying about those gut. Okay, now this is giving you a pure exponential, but what? Exponential decay, right? E to the power minus j omega. So it is giving a pure minus. So your response curve will be like an exponential decay, like this. That is what here. You can just go an exponential decay like that. So the curve is exponential decay. So it is also not making any trouble to the response. So you are getting anywhere, all exponential decay curve is coming. Good, this is done. I think everybody understood up to this. Now we are jumping to the next pole with the cyan curve, with a cyan color. With the cyan color means on the left half of the S plane. That means this is the cyan color, this one and this one. This one. So if this is the thing here, then square, right? So for the cyan color on the left hand side, two conjugate pole. You see this is under damped case response, right? The cyan color on the second quadrant and third quadrant. If the conjugate poles are located, now look at this. This is done. Hello, I'm talking to the live class. You try to get my point here. These two conjugate pole, if you consider, then both are containing the imaginary as well as real part. Both are having it is -2 plus j3, the -2 minus j3. So both are having the real part as well as imaginary part. So the real part and imaginary part, none of them are zero actually. This cyan point, that means the second and third quadrant on the left hand side is planes, actually indicate that these two conjugate poles are having, none of them are zero, the real part and imaginary part. So both are staying. So if both are staying here, if not zero, that means the exponential term and the sine wave term both are existing. Both are existing means if it is multiplying, then the response is the sinusoidal is going down exponentially, as we saw the under damped case. So because under damped case both are present, and then it is going down, as I told you earlier as well. So anywhere it is located here on the left half S plane, I'm sorry. All right, now let's come back. Anywhere it is on the left half S plane, like these conjugate poles, like the cyan color, here, 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 and there's the conjugate poles on the left hand side. The response will be similar to the thing, because in that case, none of them are zero, means exponential term and sine term both are present, and they are multiplying on top of one. They are giving a sinusoidal decay exponentially. That means under damped case things, they are giving us like this the response, because the exponential and sine multiply. So sine is decaying exponentially. So that's why the cyan color response will be like this. I hope that all of you understand. Now we are jumping to the right side on the purple color as well as the yellow color. Let's see. Anybody got any question can ask me. Hey, you all got it? Hello, real life. So anybody got question? Real class, I'm talking to them, to you. Is it okay so far?
Yes, sir.
Good, excellent. Thank you very much. And the next step is we are going to go for the location of other part. That means I'm going to drop it out now. You all understand up to this. These are the responses for left hand side. Now you understand that if the poles are located on the left hand side, then this will be the response. And now we are going to go next is after this, the next we are going to go for the real axis location on the right hand side. On the right hand side of the real axis, how it looks like. If the pole located on the right hand side, a real axis, for this one, j omega value, this is the question, be coming to positive, because the location of the pole is on the right half of the real axis. So the real value and imaginary value should be what? Be 0. Now in this case, if you look at it, the equation coming here is a 1 minus, since the imaginary part is gone, so only the real part will be there. But in this case, real part will be zeta omega n t divided by root over 1 minus zeta square. Only this part is remaining, ct equal to this. You can see after some time the screen, that part will be there because the imaginary is 0. Part will be like what? If you go with the response curve. Okay, I'm going to tell you the real life class. You look at it. In this case, actually the real part is positive because the thing is on the right side. So, and the imaginary value is 0 because on the real axis, imaginary value is 0. Like this one we have seen last time. So if you put this value here, then this is going to be zeta omega n, and this will be 0. So now substitute the zeta omega n in the exponential point. The whole thing is becoming e to the power plus zeta omega n t because it is on the right side. So the value is going to be positive here. When it was on the left side, then it was a negative, but when it's it is positive. So, and rest of the thing, and sine, this part is 0. So sine part is going to be 0, and there's a constant coming there. So you don't need to worry about it. Now, all this equation having only one function, which is exponential function, but it is exponential positive. So it is exponential, not decay, rather exponential rise. It is exponential rise because it is e to the power plus tau t. Earlier, it is exponential decay. Exponential decay means it was e to the power minus zeta omega. That's why exponential decay. But this time on this right side, that's why it is plus zeta omega. That's why it will be e to the power positive zeta omega and t. And this is exponential rise, not exponential decay. So the curve will not going to die, rather curve will go upward direction like that. That was what we can see here. Look. Okay, can you see the curve? The curve is going exponentially upward direction. Follow this exponential rise. So the curve is going up, 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 up like that. The CT output is going to infinity. Now what happened? Look at it. Do you understand this curve exponentially increase because this is e to the power plus zeta omega nt, not minus. It's exponential. Earlier it was exponential decay, but now it's exponential increase. Do you get it now? Hey, anybody?
Sure, I had a
Can you hear
question.
me?
Yes, sir.
Yeah. So it is exponentially increase means what?
Yes, sir.
Yeah. That means what? The output is increasing, increasing, increasing. Means the system output will be increased to infinity. Means what? It will be unstabilized. The system will be unstable because output is going to be infinity. Slowly, slowly, slowly. If your fan speed is infinity, you on the switch and fan speed increasing, increasing up to infinity. Will it be reach infinity? It will be stuck. And armature current will be infinity. And what will happen? Armature current will burn, smoke coming out. Everybody will get down, stump it, dead, sort of problems. So system unstable means it will be hang. A lot of current flow means it will be damage the system. So unstable is instability will be occurred if the pole locate on the real axis, on the right half real axis. Yeah, from the live class, one of you raise your hand. Want to ask any question?
Sir, I had a question.
Afraid. Yeah.
Sir, actually, I have a class at from 2, sir. That's why.
Okay, just we are going to finishing within 5 minutes time. That means anywhere put. That is the case here. That's done. Now the last one is in the first quadrant and the fourth quadrant. If it is located there, then what happened? I'm wipe out this thing and we are jumping to that so that everybody can understand. Okay, I'm going to go up to this. Okay, that part done. Now the purple thing, I'm going to bring it here. I'm going to bring it here. If the two purple dots are here, it gives you the sigma, which is not j, the zeta omega n positive, and j omega will be here as an omega n root over 1 minus zeta square t. So this is the thing. None of them are 0. Real value as well as imaginary value, both are present. which is like this one, like 2 plus minus j3 is the point. This is a conjugate point. Something like that sort of point. 2 and 3 depends on the value of zeta omega n. So the location of these two purple pole on the right half S plane or on the first quadrant and fourth quadrant are indicating this. And you understand up to this, right? Up to this is done. That means you are going to have this 2 multiplication. Both are exponential rise, and sine wave is exponentially rising. That means it's very simple. You please just look at it. That means this is okay. All of you can get a screenshot. That should be fine. And this is the response for the purple one, which is also unstable because output is increasing exponentially. The sine wave is increasing. That's make the system unstable. So our conclusion is okay, I'm going to tell you the live class. Look at it. In this case, purple case, actually, this is the real part and imaginary part because none of them are 0. And as I give an example, 2 plus minus j3. So both are positive. So you can substitute this zeta value is zeta omega n, this exponential zeta omega n, and sine is as it is. So in this case also same, like last time we have this exponential decay. This time this 2, if you multiply, sine wave will multiply with exponential rising. If exponential rise and sine wave, then it will be what? Just within 1 second, I'm going to show you, and then you can get it because this is also important part of stability analysis. As you can see, I think all of you can see the thing. So if you can see exponential rise and it's multiply with an exponential sine wave, something like that, that means it is going to the problem is coming here like this. It is going to go with like these and like that. That means it is exponentially it is increasing. So what happened now, then it can be, you can say that this is you're trying to get my point. It's something like this is going to be happening like this becoming unstable. Actually system is becoming unstable here if it is something like that. And it is what? Exponential zeta omega n t, and this is your sine omega n t, omega n root over 1 minus zeta square t plus phi or whatever. So sine wave and these things you multiply, and on the top is -1. That's why it's jumping on -1. So you understand it very clearly that this is the reason why on the right side it will become unstable, very much unstable. Hopefully you understand the purple response here, and purple response here is going to be increasing and becoming unstable. That means if the pole located on the right side S plane, on the right side, first quadrant and fourth quadrant, in between any pole here, conjugate pole, any pole located on the right side S plane, the response is becoming unstable because the exponential going to increase infinity. But if it's on the left half S plane, you can see it is slowly dying out, means more stable. So this is the conclusion. And also here on the left hand side is stable, but when you come here it is unstable. So on the right half real x is also unstable, but left half real x is also stable, and left half second quadrant and third quadrant also is stable. The whole left half S plane is stable and whole right half S plane is unstable. This is what the conclusion we can come forward. And this middle point, this and this is imaginary. This imaginary axis, you can see it is neither stable nor unstable. That is, it is in between. Actually, it's a very critical condition. We can say this condition is very critical condition. A little bit on the right means it will make the system unstable, and in the left means it will keep the system stable. Like this way we can conclude over here. Now let's have a look what happened. Right half S plane, any pole locate on the right half S plane will make the system unstable. Right half S plane, anywhere the pole located make the system unstable. This is our conclusion. So this is the unstable right hand, and this is the stable left hand side, stable. So we can say like this. I'm going to show you in this one. That is, this is unstable, and this is, and for the system to be stable, all the pole must be on the left half S plane. Okay, this is the conclusion. For stable, any poles, at least one pole located on the right half S plane, that is quadrant 1 and quadrant 4 whiteboard, I hope.
It will be the time. Okay, sir. So it will.
Okay, all of you can hear me now. I'm coming to the live class. I hope that you all understand. The conclusion is this, that if any pole locate on the right half plane, system will be unstable. I'm just going to show you. This is very, very important part. From now on, we have to go with this thing, and we have to come up with this conclusion. Can you just, I'm going to finishing it just to show you here. So this is what actually we have shown, the unstable region of the S-plane, and on the left hand side is the stable region, a stable region. So a single pole, if located on the right half S-plane, will make the system unstable. So for the system to be stable, all the poles must be located on the left half S-plane. All the poles of the system should be on the left half S-plane. You make a helicopter and send it to Afghanistan, because you check it in America, desert, Arizona, and it is working fine. But when you send it to some Afghanistan area, and then you start operating the helicopter, but the environment there, the sandstorm, the weather, temperature, everything, what it does, slowly, it try to move the controller, it try to move the, what you call, close the pole from left to right, from right to left. So while this pole, slowly, this is very close to the right axis, so slowly, it will move and go to the right side. If somehow, because of those environmental issue, this pole moves somehow to the right side of its plane, and slowly the helicopter become unstable, and the system will be, the stable system will crash. If the system crash, then I think you understand what will the thing happen. That's why smart controller you have to design. Whenever the pole goes to the right of its plane, then that controller will have to bring it back to the left of its plane, so that it can become the stable system again. That's why when you go in the aircraft, go from one country to another country, you see suddenly the turbulent weather is there, and the aircraft try to become unstable, and the controller, smart controller, try to make it stable. Means what? This is the scenario. That's to try to bring all the poles back to the left of its plane. Once back to the airspace plane, system is very much stable. And if any of the pole try to go to the right side, we'll try to make the system unstable. So conclusion is, in order to make the system stable, all the poles must be closed loop pole. Remember, closed loop pole, closed loop pole, closed loop pole, not open loop. Okay, closed loop poles must be located on the left half S plane. That is what actually our main conclusion today. And next time onward, you have to remember this thing, and we are going to work on these things next time, next class onward. I think in the future, we are going through different frequency domain analysis will be based on this. That's why today's class is very important. I hope that should be fine for today. We are going to closing the session here. All of you, please just 1 second. I'm going to get a snapshot, and then you leave the room. And I'm going to ask to people stay back. Jannatul Naim, Jawadul Alam, Khadija, and Asif Imran Khan. Your marks is not updated, and rest of your marks updated. And those who can see your marks and you updated, you can just leave the room. And if you do not have any question, also you can leave the room. Now I'm going to show you the screen. Can you see the marks? Kaikat, can you see the screen?
Yes, sir.
Okay, now you can see your marks on this 22nd, this date. Actually, you can see marks is given. So those who see your marks is given, you can leave the room. Now and if you have any question, you can stay back. Otherwise, the guys have to stay. Okay, Jannatul Naim, what is your number? Please be faster. Serial number, Jannatul Naim.
Last one, sir.
Last one. Which one? Or last one? This one. Okay. Okay, Jannatul Naim, thank you very much. You can leave the room. And then send next guard is your Jawadul Alam. Where are you?
Sir, 27.
27 Jawadul Alam here. 27, you get 0.25. Okay. Jawadul Alam. Next, and rest of you can go. If you want, you can leave the room. Okay, Khadija, where are you?
Sir, 33.
33 here, 33. Okay. Khadija should get 0.1. Okay, fine, no problem. And next is Asif Imran Khan. Asif, where are you?
Sir, minus 24.
Yours 24, Asif Imran Khan 24. Is this one? Okay. I think the rest of your marks is already updated, and I think now you all can go. Yeah, yeah. So we can entertain the question. Now let's come back to the point. Who is the guy? Rest of you can go. Those who have class or anything, because we don't have anything to other than you have any question. Yeah, question who?
Sir Afsan.
Rafsan, yeah. Tell me what is your problem?
Sir, when you were finding out the stability of the system, sir, when you were using the formula 1 minus exponential zeta omega t sine, sir, that formula, sir, so when you're subtracting omega term and the sine term from 1, sir, won't we ever get a negative value for the whole stability of the equation of the whole system?
You are talking from, okay, I'm just going to show, then we can better understand. Last one.
Yes, sir. The four graphs that you were showing.
Okay, here you're talking about this side.
Yes, sir. Sir, yes, sir. The purple equation on the top left, sir.
Yeah, this one.
Yes, sir. Sir,
Yeah,
what if it becomes negative 1 minus the right hand side? Yes, sir. This part.
Okay, yeah, 1 minus. Then which one you are talking negative?
Sir, the whole part.
Oh,
sir,
whole part, the whole thing.
Yes, sir. Sir, yes, sir.
The whole thing is
the exponential multiplied by the sine term becomes negative value.
no. The whole term is because of, oh no, you see this one?
Yes, sir.
And because of this, actually, it's jumping on the one here.
Oh, okay.
This
sir.
is for the whole thing, actually, the whole thing. Otherwise, what happened? If only these two things you consider, not one, then it will be, the wave will be coming like these. From on the 0 axis, it is increasing. On the 0 axis, it is increasing infinity. Got it? It's not on the 1. Now it is on the 1, actually, right?
Sir, sir, 1, it's like a level up, sir. It pushes the graph upwards.
Yeah, that's right. Absolutely. Because we are considering the whole thing here, including 1.
Oh, okay, sir.
Now if you exclude 1, if you forget about 1, only this part if you consider, right, without 1, then it is the multiplication of exponential term and sine term. In that case, it will be on the real axis, on this x-axis. The exponential curve will be increasing on the x-axis, slowly become bigger. You understand?
Yes,
not
sir.
on the 1.
Sir, is there any way that 1 minus exponential term multiplied by sine term, the whole thing becomes negative?
The whole thing.
Yes, sir.
Okay, whole thing become negative. Why? Because it is, you are applying 1. So 1 is always, according to the equation, it cannot be negative, right?
Yes, sir. Sir, 1 minus.
1 minus means that you're talking about this thing is more
Yes,
than.
sir.
Yeah,
Yes, sir.
this thing is more than, it can come here, because when it is coming here
It
at
goes
this
to-
time, then the whole thing is negative here, isn't it? At that point, it is negative.
Oh, okay, sir.
And
Okay,
again,
sir.
the next peak is much more negative.
Oh, okay, sir.
And that's why the plus minus is coming there. Okay, but it is unstable, because the output cannot be reached to a high value, because the fan, for example, you cannot on more than 2 ampere current, but after that it goes to saturation, is stuck. The fan will be stuck. Helicopter will be explode.
Oh,
So
okay.
you cannot go more negative. I think by this time it will
Can't be extremely over. Then.
you cannot go to the extreme up to how come you get infinity output? Infinity output is not, that means you understand that in reality is something different. This is theoretical part is this one, but reality is something different. Case by case basis, different system behavior will be different. Good.
Okay, sir. Sir, thank you.
All right,
sir.
thank you very much, Rafsan, for your question. Any other people got any other question? Tomorrow, you don't forget, tomorrow you have what? Hey, a dating with girlfriend.
Sir,
What is that?
tomorrow we have city tour, right?
Right, absolutely. I thought you forgot it.